Okay, the last section in Unit 3 is where we're going to mix them all together and do a couple of different factoring techniques on the same problem. So, just to review, there are 4 different types of factoring. We've got common factoring, perfect squares have 2 terms, grouping has 3 terms, trinomials will have 3 terms, which use that AC method. So, strategies for factoring completely is the first one is you always want to check common factoring first. You can do it at the end on some problems, but it's easiest if you do it first, okay? All right, and then once you common factor, if possible, then you are going to look at the number of terms because that's what's different for all these types, okay? So look at number of terms, and then on other assignments, it won't always factor, but on this assignment, you should be doing 2 types. So there should be another type of factoring, okay? So look at number of terms for factoring technique. Occasionally you'll be able to do it 3 times, but you just have to keep checking, okay? So is that your final answer? You'll know it's your final answer when all the terms are factored and you can't do any further factoring. So it's hard to tell and you just have to keep asking yourself. So I'm just going to write keep looking for additional factoring. And I know this is a very vague rule, but that's really what it is. Okay, so on the first one, if I check for common factoring, they actually both can be divided by 4. So I'm going to write CF, and you don't have to tell me that. This is just for you to know. So we're going to take a 4 out, which remember that means to divide. So I would be left with v squared minus 1. And we did one factoring technique, so this is partial credit. But then I look and I see, okay, we have 2 terms. So let's go back up to my list. 2 terms is we want to look for perfect squares. Since this is a minus, remember, it's the difference, and we won't have the imaginary. So that's like v squared minus 1 squared. So then we get the v's are first, the 1's are second. That looks like a 1. I'm going to make that a little more curvy. And then 1's plus and 1's minus. Now remember, we still have that 4 that we common factored out, so you need to bring that back down. And then we don't have any powers here, so that's really your clue that there isn't any additional factor. So if terms are like x to the first, then you're done. Okay. All right, let's look at example 2. So same thing, common factoring. They all have a 4 that's divisible. And they have x to the first. Remember, you want to take out the lowest power. So once again, you don't have to write this 4x, but this is really what we're doing. We're dividing by it. So that cancels, take out 1 of those x's, and we're left with 2. Divide by 40, take out an x, divide by 40, and take out that x. Okay? So we did common factoring. Then I have 1, 2, 3 terms, which was the trinomial, the AC method. So I've got A times C, and I'm just going to do it here. I need the factors of 16 that can give me 10. So I've got 4 times 4. That'll give me 8. 8 times 2. If I add, that'll give me 10. And we're going to split up the x's. So we're going to write x squared. I have my 8x next. 2x plus 16. And then that turns into grouping, but we're still doing the trinomial AC method overall. Take out an x, divisible by 2. So the outsides will go together and the insides. And then this is also forgotten, but we have that common factor of 4x. And notice x to the first is our highest power of all the terms, so we probably did it correctly and we're done. All right. Example 3, if you want to see some further, 9 divides by 3, but 16 does not. So there's no number in common, but they all do have an x. So we'll take that out by dividing it. And then 1, 2, 3, so we have trinomial. So a times c the factors of 144. This is a tricky one, but I've done 144 a lot, so I'll give you a hint. It is 12 times 12. And if we want to get negative 24, we can make those both negative and add our x. So I've got 9x squared minus 12x minus 12x plus 16. Then we do factor by grouping. We can actually divide by 3x. Let's see, 12 and 16 both divide by 2, but bigger 4. So we're going to take out a negative 4. So 3x, divide that by negative 4, and they do match. So our outsides go together and our insides go together. And they happen to be the same. Don't forget that x. And so sometimes, since these are the same, you might see it written with exponents. I will take either one because they're both correct, but you might see this, okay? But both of these are good answers, okay? The bottom one's better because it looks like the most simplified, but let's see, example 4. They do all divide by 3. And they don't have an x in common, so just a 3. Common factoring will be used the most on these problems. We've got 3 terms again. Trinomials show up a lot. So the factors of 36 that will add to give us 13. So I got 6 and 6, but that's 12. 9 times 4 if they're both negative. So x to the 4th, oops, I forgot that's squared, minus 9x squared minus 4x squared plus 36. Factor by grouping. We can take out an x squared. So divide by negative 4. And so we're left with the 3 comes down, the outsides, and the insides. And we did do 2 different types of factoring, but these terms aren't x to the first. We've got 2 terms in both of them, and they are perfect squares. So I'm going to write the 3, and then that's like x squared, and 4 is 2 squared, so 1's plus, 1's minus. Same thing here, 2 groups. That's x squared, and 9 is 3 squared. 1's plus, 1's minus. So we did 3 different types. We did common, we did trinomial, and we did perfect squares on this one. All right, so you give it a go and see how you do.